はい、京都大学の
Thank you very much. My name is Koyamada. My name is Koyamada with Academic Center for Computing and Media Studies with Kyoto University. I would like to speak under the theme of a visual data mining environment for cultural information. I am from an engineering and natural science background. First, about the visualization. I would like to give you some definition I would like to give, which is acceptable in society, and visual data mining and cultural visualization and cultural computing.
First of all, I would like to discuss a visualization in which the images and the visual images are used. And what is a definition visualization? In 1987, ACM VISCA report was published, and visualization in scientific computing was the report. And this is the definition. Visualization is a method of computing. That's how and when it was defined. So symbolic and invisible data is transformed into geometric data, which is further transformed and converted into the image data. In other when you can see supercomputer and also measuring devices from which the enormous amount of data, and also the mesh and also triangle, and also the dots, and also the linear configuration and 9 segments are represented, and they are the representation processes. But apart from visualization process, there is some Japanese language which is coinciding with that, mieruka. So identifying the issue, and then they are pushed and also placed in the foreground of the situation. So fundamentally, it is equal to the visualization. In order to explain that, we can use a metaphor, the incredible strength arising in yourself, and what people find and within themselves in a fire emergency. So, if you meet somebody who has not seen a fire, you have to go through a pathway for the explanation and also the conviction of the help. But if another person has been witnessing the fire outbreak, you don't have to bother that transmission of information and persuasion. So it is the sharing of the sense of urgency, which is spontaneously achieved by looking at the same thing, namely the outbreak of fire simultaneously and together. So visualization clarifies the presence of a problem, and this is quite effective in the issue realization. Once it is realized by people, awareness arises, and once awareness is achieved, there is a dialogue to be started between people who share the same awareness, and then it leads you to the further thinking. As a next action should be considered. So you are motivated to take action in the next step. That result in the improvement and betterment of the circumstances. This is a chain caused by mieruka or visualization. The problem resolving is important, and so actually visualization is utilized in visual data mining for the problem solving. Data mining has been often quoted in the computing and also scientific world. Based on the observation data, modeling is achieved. But the visualization has been explained. It is one method of computing. Visual data mining is actually an incremental method of modeling using observation and simulation. Therefore, the observation data and simulation result are both utilized for that construction of modeling. This is the image and diagram of that process. Problem solving is what we want to see. But if it is just a mathematical world, computers are just engaging in computing only. But actually in the realm of visual data mining, people are actually in the loop. So human in the loop is one important factor for visual data mining. observation data result and simulation results are there. It is on the right top, and they correspond to actual, and simulation corresponds to ideal. So they are visualized. By going through the visualization, awareness is achieved on the part of humans, and among those who share the same awareness, the dialogue is triggered, which result in the action to be taken. The model construction is the next step, which people aspire to reach. This visual data mining has been already applied in various areas. Even sound, and how do those dental fricatives to be generated? The basic research has been conducted focusing on that issue. When the dental fricative is generated, there is a roundness along the length of the tongue. Therefore, the airflow is directed to the back of the teeth. Then the flow and the liquid comes out of the mouth, which is turbulent. And then turbulent vortex is perhaps a source of the sound, namely the dental fricative. So we wanted to elucidate that process. This is an observation result, which is also interesting in the presentation of the video image. When the fricative is uttered, then a particle is actually injected in the mouth. So the sort of particulate air jet is coming out of the mouth. As you see, the air was directed below and downward, but it is now changed to upward. This is not the ending. Modeling is conducted so that we can further the research program. This is what we obtain. On the computer, modeling is to be configured. The subject CT image was taken. Only the peridental slice CT images were taken. Actually, 512 slices based on which 3D structure was modeled. And inside the 3D model, there was a calculation conducted, and many days were spent by using a supercomputer for that computational stage. Computer graphics were configured, which is also part of the A form of visualization. So this is the result of the computation, and there is some narrowing in the canal, and so it happened that the structure was geared to direct the airflow to the back of the teeth. This is the top-down configuration, which can be rotated so that we can see the full facade of the face. Then we get closer to the periphery of the mouth, and you can see the color distribution. Color distribution represents the three-dimensional distribution of the air coming out of the mouth, and the particle is actually injected. So therefore, visualization is also based on the use of very fine particles. This is the frontal view from the front of the mouth. Towards the left top, you can see the lip, and somewhere around here, you can see the teeth. So around that point, there is an air jet coming out, which has been visualized in this diagram. With regard to the observation data, there was some inconvenience because it was just raw data, so somehow it was hidden by the lips. But with this visualization, it is more clearly represented. But having both, you can actually make steps forward to the improvement of the visualization model. That is how and where we stand. So what about cultural application? Cultural visualization is the next challenge we face. Globally and around the world, the media is created by an explosive number of parties, and media contents are increasing at a very rapid pace. And comments are given like track back to those contents, media contents. For the summarization meta channel has been also developed and very rapidly as well. Unless you go to a very famous museum, those could not have been displayed. But actually, wherever you are, and whatever time you want to do so, you can do that. You can access that sort of data, especially in the supercomputer facilitated universities. The data analytic function and facility is quite highly developed. They have got the infrastructure. For example, the visualization of the scientific computing is already readily available because they have such an environment. Therefore, in that university institution, there is a very good fusion of the cultural element and the visualization technology. That is a high potential from now on into the future. This is an IBM developed a history flow, which is also the visualization tool for cultural element, cultural information, dynamic and also evolving writing is the arena to which this is applied. You can see the analysis and also revision to certain sentences and also writing and chronologically this represent. And if you see one red line, this was a work of Mary. Mary wrote this sentence or this writing on her own. Suzanne actually contributed some additional part, and Martin joined this program, and a part of Mary's original writing was deleted by him. So these works and also these activities are actually represented by different colored lines, and you can see which part is connected to what. As a result, you have this configuration, which is as a result of visualization process. Wikipedia was a target. For example, with regard to Iraq, and if you access Wikipedia, you have this writing, and so many contributors contributed their writing. But once there is some event, there is a revision to that writing, and also there are different authors coming into the same, contributing their own writing. So, for example, series of phrases and also series of haiku can be actually visualized in such an environment, and if you use this particular technology of history flow. Cultural analytics is also being developed as a part of the visualization technology. Supercomputers are facilitated by various institutes, and one of them is in California University, San Diego. In that premises, and this project has been already initiated, and there is a very easy to understand video clips which were presented on YouTube. I downloaded it, and I would like to show it to you. This is a giant scale visualization scheme. You can see time display equipment and device on the wall. And on that screen, an enormous amount of picture painting data is facilitated.
Into collections of paintings. First, let's take these images and let's move them over onto part of the wall's surface, and then load some graphs on the other part of the surface. These graphs all run over the years of Rothko's career from left to right, but their heights are indicated by different features of the images themselves. Texture, brightness, number of shapes, saturation, and we can use them to explore.
はい、これはYouTube の方で5分。
So you can actually access this YouTube video clip, and it takes about 5 minutes. If you are interested in that, please take that. Please enjoy that. This is an observation data which is transformed into graphs. This is a model construction. This scheme and facility is already available, and that is interesting that one of the supercomputer center in the United States is the arena where such a scheme is underway. What about a Japanese cultural model? Dr. Toda talked about it, and I am also interested in the application to Japanese cultural aspect. I think these can be the agenda. Chinese poetry is now focused on. And the Chinese poetry, there is always a representation of the sense of seasons. And how was that sense of seasons transformed to or converted to the kigo of haiku? I don't have a particular answer to that question, but that is an interesting question. Actually, the definition of the sense of seasons is the first stage, and then that is transformed to the numerical modeling, and then it is coupled with the climate modeling, and the hitchhike haiku group and clusters are the next step you can walk into. And I wish I could show that result, but we have just started this project and it is still burgeoning stage. Therefore, all that I can show now is the actions and activities we are engaged in at the moment, and this is a rather simplified presentation of what we are doing. This is a very traditional Japanese building, household, the ordinary household building, and around that house you can see the 3D mesh. Therefore, the numerical fluid and fluidic geometrics are actually surrounding this house. The sense of seasons can be resolved and computed mathematically, and as a result of that computation is actually geometrically represented, and in the tokonoma there is a scroll of painting, and there is a convergence and also the concentration of that sense of seasons on the scroll. This is a haiku image. Hitchhike system was used and developed by Dr. Toda. I will tell you the mechanism. This is a hitchhike image, and then in correspondence to that, I defined the temperature arena, and then numerically and mathematically I resolved that equation. So the flow simulation model and hitchhike encountered. So hitchhike meeting this and flow simulation. This is a summary. With regard to visualization, I have given the outline. Modeling was the next subject, and in modeling and visual data mining can be applied. Cultural visualization is another sphere in which we can actually utilize and apply this technology. And across the world, there is a progress being made. In Japan, the sense of seasonality is very important of haiku. And in the haiku definition, we can actually use this visual data mining technology. Thank you.